morning and a very warm welcome to HDR's Talk of the Town. As always, so lovely to see familiar smiling faces in the audience and our close industry acquaintances. Absolutely super to have you here in our London office. My name is Farah and I'm the Marketing and Communications Director for the Global Building Engineering Services Group here at HDR. Before we delve into our talk, Powering the Future, Data Centers, AI and the Energy Infrastructure Challenge, I would like to share a potted history about our speaker. Paul Franklin was born in Hillingdon in Greater London. Paul's grandfather was a carpenter who worked on bus and rail coaches and spent his early years in India. Paul's grandfather would regale many childhood memories with him, which were both inspiring and mesmerizing. His grandfather was interested in craftsmanship, building engineering, and construction, and as such, Paul was immersed within this environment in his formative years. Paul's first degree is in business, and he subsequently studied for his MSc in real estate at the University of Reading and is a chartered surveyor. Paul was also a reserve officer in the British Army. His career in the early days ran parallel to his professional career between 2008 and 2018. Paul rose to the rank of captain and had a number of overseas deployments, including Afghanistan. Paul also spent time in Malawi, in southeastern Africa. Fortunately for us, Paul decided to join HDR as our EMEA TMT market sector leader in March 2026. With over 2 decades of senior leadership experience, client and consulting across infrastructure, capital programs, and complex large-scale developments across the UK and internationally, his career has been defined by advanced projects that run at pace and at scale, qualities that sit at the heart of what TMT clients are navigating today. As Managing Director of K2 Construction Management, Paul's team led and delivered CR Wind Monopile Manufacturing Facility, a 1 million square feet of advanced industrial infrastructure, and at the time, the world's largest of its kind. Before K2, Paul had held the position of Vice President at British Volt, where he established and led the project management, office, energy and infrastructure functions for the UK's first battery gigaplant at Cambwas at Northumberland, a 4.5 million square feet low-carbon battery cell manufacturing facility. Working directly with UK central government and regulators, Paul developed innovative grid, offshore wind energy solutions while also carrying an international remit across Canada, the UAE and Japan. This remains the most distinctive chapter of Paul's career and gave him a clear perspective on the power delivery challenges that now sit squarely on the agenda for our clients in the TMT space. In addition, earlier in his career at the Lei Xing Hong Group, Paul delivered Europe's largest independently owned Mercedes-Benz facility, a 330,000 square feet development in Stockport, completed under an accelerated program. In his new role, Paul will work with clients across the full project lifecycle from design through to delivery. On a personal note, Paul has been married for 12 years to Louise, has a 3-year-old son called Charlie, and a 1-year-old daughter called Elodie. I knew I was going to trip up on that. When I asked Paul if he has any hobbies in his spare time, Paul's response was, "I do not have any spare time." And so to the synopsis that Paul will explore this morning. The exponential growth of AI is driving a step change in data center demand that is fundamentally outpacing the capacity of existing energy and infrastructure systems. As compute requirements escalate, data centers are evolving from digital facilities into energy-intensive infrastructure assets, placing unprecedented strain on power grids and supply chains. Within this environment, success will require a fundamental shift in mindset and approach, positioning energy not as a constraint to manage. Instead, energy must be treated as a primary asset around which location, design, and investment decisions are shaped across the global landscape. And so, with the exam questions set, without further ado, I am absolutely delighted to invite the very Paul Franklin to take us now on a journey. Thank you, Paul.
Hopefully I can do that justice with this talk. So good morning all. Thank you, Farah, for your kind introduction. It's so good to see so many industry friends and acquaintances in the audience this morning. Thank you for making the time in your busy schedules to be here. Today I'll be talking about one of the most defining infrastructure challenges of our time, the intersection of data centres, artificial intelligence and energy systems. As demand for AI accelerates, data centres are no longer just digital infrastructure. These facilities are rapidly becoming one of the most complex energy challenges globally. So what are the key environmental challenges and AI's impact? We're entering uncharted territory. On one hand, data centres offer enormous potential to transform how we live and work. On the other, they are placing unprecedented pressure on scarce global resources. When we look at power demand, the scale is immense. In 2024, data centres consumed around 415 terawatt hours of electricity globally, around 1.5% of global demand. By 2030, this is expected to rise to 945 terawatts, more than double. To put that into context, that would be data centres consuming more power than the annual capacity that Japan uses today. This creates a fundamental issue. There simply is not enough power infrastructure available to distribute the power required. Grid infrastructure, transmission networks and substation capacity are increasingly becoming the primary constraints on growth. Artificial intelligence accelerates this dramatically. AI data centres can require up to 50 times more power per rack than conventional facilities built just a few years ago. As organisations deploy increasingly sophisticated AI models, energy demand is rising faster than many power networks can accommodate. While emerging technologies, including optical interconnects, photonic computing, and more efficient chip architectures have the potential to reduce future energy requirements, these solutions are still several years away from deployment. The result is a growing tension between supporting the rapid expansion of AI and ensuring the infrastructure underpinning it remains sustainable. The difference between traditional computing and AI workloads can be striking. A conventional internet search requires relatively little power and therefore minimal energy and cooling. By contrast, an AI-powered query involves significantly more processing power and often consumes multiple times more energy than a standard search, and generates a correspondingly increased demand on cooling loads. The gap widens significantly on complex AI models. At scale, billions of AI interactions per day translate into a substantial increase in electricity consumption across the global data centre ecosystem. As demand continues to grow, grid connections are becoming scarce, connection lead times are extending, often stretching into many years, and operators are competing for access to available electricity capacity. In response, some hyperscale operators are exploring on-site power generation to secure reliable energy supplies. However, at scale, this can introduce its own environmental challenges, including increased emissions, water consumption and local community impacts. At HDR, our power team is seeing an increasing volume of requests from clients to support power projects of these kind. Water is where public concern is loudest, and where actually engineering has moved quickest. The question is no longer how much water does a data centre use, it is which cooling architecture was it built with and when, as the answer to the second question will often answer the first. Historically, most large data centres relied on evaporative cooling for heat rejection. These systems were highly energy efficient, but very water hungry, with 80% of cooling water ultimately lost through evaporation. In water-stressed regions, this has understandably become a source of public concern. However, the technology landscape is changing rapidly. The newest generation of AI facilities is increasingly moving towards direct-to-chip liquid cooling systems. In these systems, water circulates within a sealed system rather than being continuously evaporated and replenished, dramatically reducing overall consumption. There is, however, a trade-off. Replacing evaporative cooling with mechanical cooling can increase power consumption and worsen power usage effectiveness. Modern chip level cooling systems operate at higher temperatures, which offset much of this penalty, improving the balance between energy efficiency and water conservation. As a result, many headline figures on data centre water usage reflect older generations of infrastructure rather than the designs being deployed today. Water remains an important consideration, particularly in water-scarce regions. However, advances in cooling technologies are steadily reducing its significance as a long-term constraint. AWS, for example, has publicly committed to being water positive by 2030, and this has already achieved around 50% of this target. Most other hyperscalers have similar published ambitions. The challenge for the industry, therefore, is to upgrade and manage existing stock, which utilise direct utility connections for their evaporative cooling. And finally, waste. Global e-waste increased 82% between 2010 and 2022. And with increasingly short refresh cycles, particularly for AI hardware, data centres are a material contributor. AI accelerates this obsolescence. Chipsets are becoming outdated within very short life cycles, 2 to 3 years, and facilities require constant refurbishment, therefore. These pressures, power, water, and waste, are interconnected. This means long-term strategic planning is no longer optional, it's essential. Energy and infrastructure constraints. I'm now going to do a UK focus. So traditionally, data centres are clustered in zones, which have been designated through planning. However, data centres that are 100% AI are changing this status quo. This is because these facilities do not need proximity to users in the same way as cloud compute does, meaning they can actually be located in previously overlooked geographies, closer to power, as opposed to closer to the end user. The UK government's answer is AI growth zones. The ambition is for 5 of these zones to facilitate more than 500 megawatts of on-site generation. In parallel to this, we have the evolving issue of inference AI, which actually pushes the developers back to traditional clusters to preserve latency, which is still pushing developments in constrained areas with resilience challenges. The UK faces major constraints on power, particularly with grid capacity. There are around 140 projects currently seeking grid connections, requesting 50 gigawatts of capacity. That exceeds the UK's entire peak capacity of 45 gigawatts. The result? Grid connections delays of up to 15 years and standard waits of even 5 to 10 years. And what's worse, only 50% of these projects actually have funding. In terms of policy response, I mentioned AI growth zones a moment ago. The UK government is responding with AI growth zones, with the ambition for fast-track planning and priority grid access. The example on the screen is the North Wales AI growth zone, which was launched with much fanfare and has the laudable ambition to regenerate an redundant industrial area. However, whilst these zones have been announced, there is little tangible evidence of delivery. Private sector response. At the same time, private capital is following power. And if you'll forgive me, as Farah mentioned in a kind introduction, there's a personal observation here in the northeast of England. So 5 years ago, I was standing on a site in Camas near Blythe, Northumberland, leading the programme for what was intended to be Britain's first battery gigafactory. Today, the same site is being transformed by QTS and Blackstone into a multi-billion pound hyperscale AI campus. We've actually got James House here who delivered the planning application for that scheme from Turner and Townsend. Sorry to embarrass you, James. The grid connection challenge is largely unchanged. What is changing the scale and value of the demand is the demand sitting behind it. In just a few years, the market has shifted from electrifying transportation to powering artificial intelligence. If you want to understand how quickly this sector is evolving, that single development in Northumberland tells the story. Camas is a powerful example of a broader trend, capital increasingly flowing to locations with access to abundant, reliable, low-carbon power. Positioned close to the North Sea Link, the interconnector connecting the UK with Norwegian hydropower at 1.4 gigawatts, along with access to multiple gigawatts of future offshore wind, it is exactly the kind of energy advantage that hyperscale operators are seeking as AI drives unprecedented demand for power. Now, Scotland is an alternative. Scotland is emerging as a particularly attractive location. For example, Scotland offers around 70% renewable electricity, cooler climates, significantly reducing cooling demands, and a strong offshore wind pipeline, 30 gigawatts potential, and the genuine prospect of off-grid renewable power data centres. One of my colleagues in the power team, Austin, who's sitting in the second row, is actually working on a 100% renewable powered data centre in the Scottish geography, a real first for the UK. However, it should be noted that these challenges are not just relevant to the UK. Amsterdam has imposed a moratorium on new data centres, and at 2023, Ireland's data centres accounted for over 21% of the nation's electricity supply. There are 6.5 billion euros of stranded Irish data centre projects without grid access at the moment. All new data centre projects in Ireland are now required to secure 80% of their power away from renewable supplies rather than from the Irish grid. Power availability is now the primary driver of location. The starting point should always be clean power, but at this stage in the race, the availability of power comes first. So how is AI changing data centre design? We are seeing a fundamental shift from buildings that house technology to integrated energy systems. Direct liquid cooling and immersion cooling are becoming essential. Systems can be closed-looped, filled once and reused. This dramatically reduces water use. This approach also lowers total energy demand. And on Portugal's Atlantic coast at Sines, there used to be a coal-fired power station. When it was decommissioned, it left behind two things: industrial land and enormous pipes running into the ocean. Start Campus looked at these pipes and saw something nobody else did. The campus will be cooled by the Atlantic through the very same pipework that cooled the coal plant. In addition, Start Campus has articulated a commendable ambition for this development to be 100% powered by renewable energy. Perhaps one of the most exciting innovations in the sector is the use of waste heat recovery. For example, the proposed Swansea Data Centre, Eco Homes and Tidal Lagoon master plan is designed to harness energy generated by the tidal lagoon to provide renewable power while also reusing waste heat through the district heating network. And at HDR, our Scottish Power team is supporting the Scottish Government's working group on developing a thermal network. The growing adoption of AI data centres is making heat export increasingly viable as these facilities generate higher grade heat that can be more effectively captured and redistributed for domestic and industrial use. Another significant shift facing the industry is the rapid pace of technology change. As computing and infrastructure requirements continue to evolve, technology can advance so quickly that early phases of development can become outdated before later phases are completed. This challenge is driving phased development models, enabling infrastructure to be deployed and upgraded incrementally, and greater design flexibility, allowing facilities to adapt to emerging technologies, changing customer requirements, and future capacity demands. My key message to you is every watt now matters. Generated, consumed, recovered, reused. So, what are the bottlenecks to scaling AI data centres? The sector faces several critical constraints, many of which are occurring simultaneously. I've spoken a lot about power, but power availability remains the single biggest constraint on new data centre development. Modern facilities require enormous amounts of electricity with large-scale campuses, often demanding power equivalent to that of a dedicated power station. Where grid connections are limited or subject to lengthy delays, operators are increasingly turning to on-site power generation solutions, often combining renewable energy sources, gas-fired generation, and battery energy storage systems. This approach helps ensure resilience while enabling developments to progress despite constraints on grid capacity. Water and cooling infrastructure are emerging as another major constraint on data centre development. As demand for high-performance computing and AI workload increase, cooling system components are becoming scarce commodities. The supply chain for liquid cooling technologies, in particular, remains significantly undersupplied relative to market demand. This means increased competition for specialist cooling equipment, longer lead times for critical components, greater focus on innovative and water-efficient cooling systems, and early procurement strategies being required to secure supply and minimise project delays. As a result, access to cooling infrastructure is becoming just as critical as access to power in determining the viability and delivery of these projects. Materials and supply chain capacity are also becoming increasing significant constraints. These include limited global semiconductor supply, shortages of critical electrical infrastructure, including transformers and switchgear, and extended lead times for specialist equipment required to support large-scale developments. In response, even the largest technology companies are seeking greater control over their supply chains, with some moving towards the vertical integration of chip design and production to improve resilience, reduce risk, and secure access to essential components. The industry is also facing a growing shortage of skilled labour across the entire project lifecycle. As we're all aware, there is an increasing deficit of engineers, technicians, skilled construction workers, and specialist commissioning and operations personnel. As demand for new data centre capacity continues to accelerate, competition for talent is intensifying, creating rising labour and project delivery costs, increased pressure on recruitment and retention, potential quality and delivery risks, and greater reliance on training, automation, and specialist supply chain partners. Addressing these workforce challenges will be critical to sustaining the pace and quality of future data centre developments. The key message: every critical dependency, power, water, components and labour, is facing pressure simultaneously. These challenges are highly interconnected, meaning that addressing a single constraint in isolation will not be enough. Success will be taking a holistic approach to managing infrastructure, resources, supply chains and workforce capacity across the entire development lifecycle. The challenge is no longer solving one bottleneck, it's navigating all of them at the same time. So I'm going to go through some emerging solutions and some real examples. So we're now seeing some practical scalable responses. Power-first real estate is coming to the fore. A growing trend in the market is the adoption of power-first real estate strategy, where access to power is secured before development plans are advanced. We have an example of this, a live example of Tritax at Heathrow, where they acquired land with an existing grid capacity and connectivity. They formed a partnership with a renewable energy provider, which reduced the expected delivery times from around 10 years to approximately 3 years, so putting power ahead of the development. This approach highlights how securing power availability early can significantly accelerate project delivery and create a competitive advantage in an increasingly constrained market. Microgrids are also emerging as an increasingly important solution to power constraints, enabling operators to secure resilient, independent energy supplies. We have the example of Pure DC and AVK in Dublin, a €1 billion investment which is announced to deliver 110 megawatt on site. This incorporates combined heat power, battery energy storage and renewable fuel capability. This integrated approach enables the facility to operate with significantly reduced reliance on the grid, improving energy resilience while supporting the growing power demands of modern data centres. Looking further ahead, nuclear energy, and particularly SMRs, are increasingly being viewed as a potential long-term solution. Some key developments include Amazon, which has announced ambitions to support the deployment of up to 5 gigawatts of SMR by 2039, and the UK government planning to couple AI growth zones with SMR developments to help provide large-scale reliable power for the next generation of computing infrastructure. While still in an early stage, SMRs have the potential to deliver low-carbon baseload power at the scale needed. A clear pattern is emerging across the sector. The organisations best positioned for success are those that view energy as a strategic asset rather than simply a development constraint. In an environment where power availability increasingly dictates location, scale and speed to market, competitive advantage belongs to those who can secure, generate and manage energy efficiently. Rather interestingly and timely for my talk to you today was Meta's announcement this week, which is to create an entire network of energy infrastructure to support their Hyperion data centre in the States. 10 gas-fired power plants, 2.5 gigawatts of solar and 240 miles of transmission cables. I'm sure that's an opportunity Austin would love to get his team onto at some point. In the race to deliver AI, the winner will be those who put energy at the centre of their strategy, not those who treat it as a hurdle to overcome. So a call to action. We're now at a pivotal moment in the evolution of the data centre sector. Data centres can no longer be viewed solely as digital infrastructure facilities. Increasingly, their success is determined not by computing capacity alone, but by their ability to secure, manage and optimise energy at scale. Fundamentally, these organisations are becoming energy businesses that happen to run computers. In the race to support AI and growing digital demand, access to power is rapidly becoming the defining competitive advantage. The challenge at this moment in time is the industry has reached a point where multiple operators are competing for the same scarce resources: power, water, equipment, land and skilled labour. Too often, these challenges are being addressed independently, resulting in duplication of effort, increased costs, slower project delivery and reduced overall efficiency. Addressing these challenges will require a more collaborative and coordinated approach across the industry. Key priorities include coordinating long-term planning, shared infrastructure and investment strategies, and greater collaboration across the entire ecosystem. This will require stronger alignment between data centre operators, governments and policymakers, grid and utility providers, and local communities. No single organisation can solve these challenges alone. Success will depend on building partnerships that balance economic growth, energy resilience, and community benefit. The future will be shaped not by individual action, but by collective coordination. The next 3 to 5 years will be a defining period for the data centre industry. The decisions made today will have lasting implications for energy infrastructure and supply, planning and regulatory frameworks, economic growth and investment, and the communities that host these developments. The choices we make now will not only determine how quickly digital infrastructure can scale, but will also shape the environmental, social and economic landscape for decades to come. The window for action is short, however the consequences will be long-lasting. If my voice holds out, I'd like to leave you with one final thought. We've already have many of the essential ingredients for success: the technology, the capital, and the political momentum. However, we now need the coordination to match that ambition. If we can align industry, government, infrastructure providers and communities around a shared vision, we have an opportunity not only to meet growing digital demand, but to shape a more resilient and sustainable future. The challenge is significant, but so too is the opportunity. Thank you all for listening and persevering my voice, and now I'll hand you back to Farah.
So, would one lovely client in the audience kick off and start the ball rolling with a really good question?
I'm Libby from Bureau 4, I'm a project manager. Just picking up on, there's like 10 to 15 years delay on power and also the push towards renewable energies. But some of these power generation companies are already saying they're not taking orders until 2028. Are we not 3 to 5 years off of having an absolute halt on site and nothing being able to progress, no materials and all of that?
So a couple of examples in the presentation. So we see increasing requirements for on-site generation, and we're also, more interestingly, seeing requirements for actually coupling renewable sources into storage systems for energy, which then power the data centre. And Austin is in the audience, is working with the first one we're delivering of these in the UK of its kind. You know, harnessing renewable power that is there and coming into the UK, putting that into storage, and then using that for the development. So there are challenges with that, but what we're seeing is people cannot wait for the grid. You know, no one has a business plan that says, I'm going to start a business in 5 years. You know, you want to start earning your money as quickly as possible. So we're seeing more and more requests for innovative solutions, be it gas-fired power generation, be it battery storage linked to offshore, to support these projects.
Andrew Talbot, just a little bit of a skeptic about the government taking a big leading role. They're not exactly nimble. You know, private industry absolutely is ahead of the curve. Can you just address that dichotomy?
Yeah, absolutely. So the AI growth zones, they've been announced with huge fanfare, but there has been very little tangible evidence of anything moving forward. What government are doing is there is a massive investment in terms of cash into the national grid, as Austin mentioned. So the national grid have a very deep purse to bolster the energy network. But what we're seeing more and more is private capital finding innovative ways of bringing in private wires or on-site generation because they cannot wait long enough.
Ellie Evans from Volterra. You mentioned communities, and I wanted to know whether you've got any great examples of best practice for community benefits packages, because I think often communities feel that these are massive developments that get done to them in areas often where they're used to lots of open space and nature, and then the community benefits packages maybe don't stack up for the disbenefits that they feel they experience.
I suppose the example we cited in the North East of England, so the QTS scheme, that had an incredible financial contribution off the back of that into the local council, which was publicised as part of the planning application. So that money would never, it's the sort of money that part of the world would never ever see, and that could be transformative for that whole region into the council. So I believe that's gone into opportunities to develop and support the community, public transport, rail networks and those sorts of things. So that's a real benefit in terms of because the planning contributions can be made to the councils, but also the district heating. You know, actually, if those systems are available, and there is some controversy about in the press at the moment about the pricing of those systems, but there are ways of these developments actually providing a community benefit.
Fantastic presentation, thank you, Paul. I was just checking some of the sites in the UK that actually have power here. There seems to be slow pickup from tenants. And I just wonder, is there any sort of negativity, particularly around the UK and our own provision for power generation, that is causing some negativity for us in a globally competitive market? Are there sort of hyperscalers out there that maybe have their focus drawn to other parts of the globe just simply because we seem to be more adversely affected?
So I'll take a first pass at this, and then my power colleagues want to jump in. So it's interesting. So in my previous life in the battery and energy business, we looked a lot about the power, the landscape of power across the European market. Now, if you're buying power in somewhere like Finland or Sweden or Norway, you're getting clean and green power, and it's a fraction of what you're charged over here. And for an AI data center, they could be consuming £100 million worth of power a year. Well, if you can save 50% of that cost because you get your power, or even greater than that, you get your power cheaper by having your facility developed in a different jurisdiction with a different power charging structure. Well, actually, that's quite compelling. You've then got the competing issue of actually, we've got a skilled workforce over here. We've got the ability to lift big projects. You try doing a project 6 hours north of Helsinki in Finland. Actually, it's pretty difficult to get people, materials, and what have you. So you might get cheap power, but then you've got a challenge of construction. So there are competing challenges. But certainly the cost of power, with our transmission charges and all of those things that are levied on power in the UK, mean that our power cost is way above any other European country. I don't know if there's any.
Gotcha. So you're saying it's more about the cost of energy as opposed to having confidence in our grid, essentially, and the provisions that we're putting in place for, as you say, the next generation of data centres.
So the grid, I mean, actually, the UK grid is reliable, and our client, I haven't heard a single client say, I don't trust the UK grid. Actually, grids elsewhere, there are some questions, but the power, the landscape of the charging structure is just completely out of kilter in the UK.
Hi, my name's Ben from Orbit Architects. I just wanted to ask how viable it is to reuse or recycle the waste heat from the data centres on a large scale. Is this being trialled anywhere or tested?
Yes. Yeah, so I know there are some issues in the press with how expensive this has been for local communities, and I think there's some questions to be answered there. But genuinely, the waste heat from these facilities, very straightforward to use that in a district heating system.
Ian Miller, TTSP. I think the problems you've outlined today, I would say, are pretty known and have been known for a while. They're problems which are within the industry's remit to resolve, and they're complex, but we're working on them. But you touched on it at the end, and maybe it's not a subject for today, where you see the interplay of, because all of these things are going to constrain development. But what we're seeing is the political environment changing, and changing quite significantly as we've scaled up, particularly at a local level. And I wondered where you saw that influencing the constraints on data centre developments as these schemes come forward. We've all got Fox Club and those sorts of organised environmental and Friends of the Earth report coming out very recently. Just wondered how you saw that influencing the future.
Well, it's likely to be a massive influence. So we talked briefly about the Scottish AI growth zone. So announced that with a load of fanfare, and then the SNP put in the press that they're potentially putting a moratorium on new data centre developments. I mean, it's complete chaos in the political landscape, because the environmental groups and the politicians, they're probably not aligned on the facts. I talked a bit about water. Okay, so it's not a misconception, but historically water has been a real problem with these developments. Well, actually, we're solving that problem by these closed loop systems. I think it's incumbent on us as an industry to explain what we're doing, because you talk to someone in the street or in the pub about data centres, and they talk about stealing all our power and using up our water. Well, yes, they are power hungry, but actually the water problem is being solved. So I think there's a big messaging piece that we as an industry need to be leaning into. But I don't think there's any silver bullet. It's going to be a challenge going forward.
Thank you all once again for being such an informed and super engaged audience. Thank you so much for your questions. I just want to say we really appreciate your support and engagement and your contribution to this conversation, which I think we're going to see out for quite a few years to come, until there's some alignment between the providers, the utilities, the governments, the policy landscape. This is such a huge challenge, and I think the narrative will be played out for some years to come.